So today I'm going to tell you all about passive thermal mass in deep winter greenhouse or any high efficient passive solar building. Let's get to it. It's like living in a solar oven or something. Warm in the winter, but also super cool in the summer. So behind me is 24 45-gallon drums, which are all filled up with water, and that equals 4,800 liters of water, which is equal to a weight of about 10,500 pounds. So these 45-gallon drums, I first put them on some thin conveyor belting so they didn't sit right on the black concrete. That conveyor belting is black. The first level of drums, and then some 5/4 deck boards, and then the next level of drums. So this sucker is extremely safe and solid on my flat concrete, flat, perfectly level concrete. It is super, super safe. Okay, now one thing I did is when I got these used barrels, first of all, you get the steel ones. Steel will transfer the heat to the water because it's a thinner material. Steel is a better heat transfer than plastic. So if I did black plastic barrels, it would, this whole thing would last forever or much longer, but it doesn't transfer the heat to the water as good as steel. Now, steel, they're filled with water, and condensation things, steel might not last forever. And it was really hard for me to find some information on like how to store water that's not drinking water just for thermal mass. Like there's not very much information on this type of thing that I was able to find. But what I got was used barrels, and what they had in it is food grade fish oil. Now, of course, I looked up, what's different rust inhibitors, what type of oil is a good rust inhibitor, and it turns out fish oil is one of the best rust inhibitors. So in each one of these barrels, they have a kind of a lining on the inside, and there's a small amount of fish oil in each one. Now, with any type of metal, you don't use bleach or chlorine to sterilize anything because that oxidizes and creates rust. So all I did was open the lid, fill it up with water to like 1 inch to the lid, and that fish oil is kind of in the water. It's probably coating the inside of the barrel a little bit. It is probably going to come up to the surface because water and oil don't mix. So at the surface, and maybe prevent the water from oxidizing parts of the barrel, things like that. Now you don't fill the barrels completely up because of expansion and contraction. So when water heats up, it's going to expand and get bigger. So you need room for the expansion. And then when it cools off, it's going to get a little bit smaller. It's going to contract. So when I put the lids on the barrels, I just put them on like a quarter turn. They're nice and loose. Actually, when I got these barrels from outside, they were in the sun, and unscrewed some of the barrels. I had a few barrels that actually concaved and like almost exploded and stuff because they were sealed up in the sun. I should have loosened all the caps off of, but the cap would like blow off when I was taking them off when there was nothing in them. So it's going to expand and contract. Now I put deck boards instead of solid plywood because the top of each barrel has the bung that's going to expand and contract, and those deck boards, it has the airspace, so it's going to let it breathe when it heats up and cools down. And this system is completely passive. So there's no moving parts. I filled it up with water, did it properly, and it is just going to stay there. There's nothing to screw up, no pumps, no nothing. So today I'm just talking about passive. Another passive part is just the concrete thermal mass that I painted black. So there is in-floor heat pipe in there that goes to a manifold, but whether I get that set up, I probably don't even have time to get it set up for this winter, but we'll see, maybe I will. But that would be a more active system, the in-floor heat pipes, because you have, you know, a insulated tank for the system, and then pumps for the system, and that's, you know, moving parts to it. That's more of an active system. So just the barrels and just the black concrete that's only going to be exposed in the coldest part of the year. So it's the end of August right now. That sun is just going to be hitting this black concrete pretty quick. As it gets colder outside, the sun's going to move up, and as it gets really cold, it's going to hit the bottom barrels. Then there's these barrels, and then at the coldest part of the year, the winter solstice, it's going to hit all those barrels. So the sun shines in the winter when it's cold on black barrels. These kind of have a glossy finish. I did buy a big can of flat black spray paint. I painted this one flat black because flat black will absorb more of the sunlight than glossy black. So I did clean them up really good, and I think I'll get my sprayer out and I'll spray it all flat black at some point, but not a priority now. It works kind of either way. Now, the concrete. So again, we poured that 4 inches thick, thickened edges, in-floor heat pipe. I let that cure for the full 28 days. And then what we ended up using is a 1 coat, 1 part epoxy paint and primer, I think it's called. And that went on excellent. You just roll it on nice and thick. The black I did, I think just 2 coats of the black, and in where the sun hits in the summertime, I did white to begin with, but it looked a little bit too much like a hospital type of thing. So I did a earthy tone and got kind of a nice sandy type earth tone, and it's a much better feeling in here, and it does the same thing as white. So doing a temperature test, there was quite a significant difference between the sun hitting the light colored concrete, the sun hitting the black concrete that is in the sun, and no sun hitting this black concrete. So this is in the shade. You can see the sun line. It's going to start to hit the whole black concrete back here. So this is kind of like, you know, if living in a solar oven. Like there's little plans to make a solar oven where you can bake stuff in, and it's essentially just glazing angled to the sun and then black on the inside, and the sun's going to like make an oven. So what I want is that sun to not reflect light but absorb light in the concrete, and not reflect light but absorb light into where I want it to. Now the white tin is not going to absorb. The light colored concrete is not going to absorb, so it's not going to heat up as much, but it is going to reflect light. And it's a funny thing that the building, only so much sun comes in, but then you control where you want the sun to stay. So I want it to reflect off poly, reflect off the roof poly, even though it's not direct sunlight, reflect off my light colored tin on the wall, because I don't want my wall and insulation to heat up. I want my thermal mass on the inside of the insulation to heat up. Under this concrete, I do not have any insulation. So again, in my shop, I insulated 3 inches under the entire pad. And so the concrete's a heat sink, and not much heat gets sucked down or sucked out. So my shop, I lost a little bit of the heat sink nature, passive heat sink nature. But this greenhouse, I have 16 inches of insulation around the perimeter, down underground, and then horizontal insulation just below surface, out like 8 to 12 feet around the perimeter. So all of the clay and gravel that I packed under the concrete and this dirt. This is all just a heat sink, but the sun's going to hit the concrete, warm up the concrete, and passively, so no air tubing underneath, like no water pumps or moving parts, just the passive concrete is going to absorb the sun, warm up during the day, and then disperse it back at night. The sun's going to hit the water in the barrels, warm it during the day, disperse it back at night. So, and when I want it to. So right now it's really hot day, end of August actually. It's plus 34 Celsius outside. It's slightly cooler in the greenhouse than it is outside. But in the cold part of the year, when it's minus 30 outside, and this is literally like a solar oven, like maybe I'll be able to fry bacon or something here in the wintertime. I don't know, but you want all that heat. Now for the barrels, or I guess one other thing here. So I have 50 barrels altogether. This is a 24 barrel system. Now I'm waiting on parts for my rainwater tanks, but those are going to be 9,000 liters. So 9 1,000 liter tanks stacked 3 wide, 3 high, coming in with rainwater just in the summer months. So not when it's frozen outside and you don't get rainwater. I'll just close it off and divert it. But I have to do some sort of filter system. Now, these I don't want to get hit by the sun, but they are going to get hit by the sun. So you can get, for $40 or something, you can get an IBC tote protector thing that prevents the sun from creating algae from your system. But because the sun just comes from the south and everything else is shaded, I'm just going to like drape probably just a light colored one in front. And I might even put some of these tanks, after this whole system is set up, in front of it. I'll have to think about that, because once in a while I'll have to probably get into this system to do some minor maintenance once I work out all the kinks, so I don't want to have these in the way. But so I think overall, once the whole system, rainwater and this thermal mass, so far it's like over 30,000 pounds of water thermal mass at the back. So 4,800 liters, and then 9,000 liters. Now, my initial thought for forever and ever, I have some pallet racking that I purchased. And I was going to put pallet racking at the back of the greenhouse, and I was going to put these rainwater tanks in the top corner so they didn't get hit by the sun. And then also you have water higher up so you get more pressure. But dealing with water, like how much it weighs, 30,000 pounds of water in here, I didn't feel it was a super safe thing. Even if I beefed it up to have the heavy water on the highest part of this pallet racking and the load points just of that pallet racking legs, like this kind of disperses the weight a little better. And it's a lot of weight. So hopefully my, 4 or 5 inches of concrete, super packed gravel, packed clay, virgin clay, that it's not going to sink my pad down at the back with all of that weight. I think it should be okay because I did it properly. But anyways, so again, light colored things reflect the sun. So only so much sun comes in the building. The sun comes, it either gets absorbed on the barrels or it hits this and reflects. So even though this could be in the sun, you can put your hand on it, it's not going to be hot, just a little bit warm. That's because from the sun, it's going to bounce off. So maybe wherever it hits the tin, it'll bounce off and then kind of absorb in the in the concrete or somewhere else. But my walls are 12 inches thick. So that's the lumber, and includes the lumber framing and the 9 inches of insulation. That's R48. So this is, I'm going to have barely any heat loss. So I have my structure full of insulation, my vapor barrier, my white tin that I don't want the sun to be warming up my wall. I want it to be warming up thermal mass inside the structure. So just like that. So essentially, you lose a lot of floor space. Like each one of these drums is 23 inches by 3 feet high. So out of this 8, I lost 16 square feet. Yeah, 16 square feet for this. And this, it just became part of my wall. So now instead of my wall being a foot thick, now it's 3 feet thick. And I lost that floor space, but it's worth it for the passive system like that. Now it's nice to use barrels, not square tanks or something. So when the sun's coming in at this angle, it's hitting the barrel at different angles, straight on kind of thing, and at different angles. So it's sucking up all that heat from all over the place kind of thing. Now, I guess another thing, back here, I'm framing in my 4-piece bathroom and a sauna building around the wood stove out of steel and concrete board and brick and stuff, all completely fire. I don't want any risk of fire. That's why I metal everything, concrete everything. There's no risk. You could have a bonfire in the middle of any one of my buildings and, you know, I'm perfectly safe, essentially. But this is going to come out, I think it's 6.5 or 7 feet. So that sun is going to hit the concrete and then it's going to have a wall to deal with. But in the sauna, I'm putting a good screen door with an opening hidden screen I bought used. So the winter sun's going to actually go in the sauna. So during the day, that sauna is actually a passive solar sauna, but just in the wintertime when you want it. And then the rest of the wall that's not a bathroom door or a sauna door, I'm either going to put, again, reflective tin and then some sort of, because I don't really have enough room for a 2-foot barrel there, or maybe I will, like do 3 barrels high or something. But again, then I'm just digging into my floor space. So then I'd only have, instead of 9 feet, I'd only have 7 feet for all my potted trees and tray rack starters and things. So I might just do a pool heater, like 3/4 inch or 1 inch PVC pipe coiled up, or one of those evacuated tubes on the wall, again, where there's not doors for the bathroom or the sauna. So this becomes my passive solar wall. And then actually in the sauna, I have my wood stove there, and it's going to be lots of brick and mass and things when I frame it in. Got some concrete boards for it. But underneath one of the sauna benches, I'll be putting in some more drums filled with water again. Underneath the top bench of the sauna. And that's just going to be solar mass too. So the sun will hit it sometimes. The wood stove will kind of heat it up a little bit, but just having that mass in that dead space is just going to, again, help equalize the greenhouse. Because again, it's the way this is designed in the winter time, when the sun is out and it's minus 50 Celsius. Last winter, before I had all this black in here, it got to plus 35 Celsius on a sunny day. So it's going to get really hot. I might even have to like release some heat into my shop, or actually like open doors to the outside when it's minus 50, because it might get too hot. But when it gets too hot, I want all that water warming. And then when it's minus 50 at night and you have no sun, all my heat loss, or my only heat loss really, is on my south end. But if this acts as that heat sink, it's going to just radiate back all night in minus 50 till the next day when the sun comes out and hammers that. The whole thermal mass concept also works in my walk-in cooler. I like storing a lot of bottled water, just old milk jugs that I bleached out and filled with water, and line them kind of in the dead space and the backs of the shelves and things. It's the same concept. Maybe your grandma or something would have some milk jugs filled with water and put them in their deep freeze. So if there is a power outage, that's cold thermal mass It's going to take a long time for that ice to melt and equalize to the outside temperature. So if I get a power outage in my walk-in cooler or deep freezes, I have thermal mass water storage in there, and it's the same concept as how I want heat in the greenhouse, and actually in the greenhouse cooling as well. The coolest spot and cool, because they're shaded, kind of is like air conditioning as well. Warm in the winter, but also super cool in the summer. So nice. So I would recommend this. This was a Bear product from Home Depot. It seems to be holding up well. A few places I was like dragging something heavy. I got a little chip, or it looks like the paint wore, but I've got some spare paint to just patch it. I did add a anti-slip product to the paint, and it feels really nice on the bare feet when the kids are ripping around on their bikes on corners, or it's wet, or there's a little bit of a ramp into the greenhouse. I didn't want to slip, so I added that to it. But I'd recommend it. It was the cheapest way. Epoxy super expensive, dyeing the concrete super expensive. No guarantee you're going to get it jet black. This got it jet black. One thing about a black floor is it shows everything. So there's dog hair, footprints, bike tracks from the kids, but it is what it is. I can just take the hose when I'm watering and kind of hose it all off, and it works really good. Yeah, again, for thermal mass, I painted this door because this door can heat up and you have to walk through. It's not a solid part, so flat black. My overhead door that's currently open, I also painted black because get it to absorb heat instead of reflect heat. And then where it doesn't matter about the passive solar, because in the winter this door, the overhead door, is always closed. Nice for working. It just makes it brighter for a working area or my butcher shop and whatever I'm doing in here. The light colored concrete again, because the sun's not going to hit it, so it doesn't matter about the thermal mass. So another thing about these barrels, they are 23 inches diameter by 36 inches high. So for a workbench in a kitchen, your countertop is 36 inches high. So if you put a thin workbench or built it like a 2x4 and then plywood and whatever surface, or a piece of stainless, and made these into permanent non-movable workbenches, you could also integrate these thermal mass barrels in other parts of the greenhouse. Like let's say I wanted a workbench on this back wall or under this sink. I could put a barrel here, and at a certain type of day when the sun's in the morning, it kind of hits this wall, and that's going to work. So these barrels, kind of anywhere you can stand it, as long as it's permanent, because once they're filled with water, they're too heavy to move around. And they do take up a lot of square feet, but when I went vertical, this only is 16 feet by 2 feet. So I guess 32 square feet of floor is what used this up, but going 3 high and the proper design that the winter sun is going to hit them. So if the sun never hit these top barrels, if you didn't design it properly, then there's not a lot of sense to having it. I mean, it's still thermal mass that just equalizes the temperature. But actually, here's one more concept to think about. They sell programmable thermostats for your house. So that's when the kids are off at school and everybody's off at work and nobody's at the house, you can program your thermostat to go down in temperature a little bit because nobody's in the house. And then you can set it to an hour before the first person gets back to increase the temperature. By doing that, I think it actually costs more in natural gas or electricity or propane or whatever you're using than just leaving it a constant temperature. because when it's, you let the house cool and then you want to call for heat an hour before somebody gets home, that furnace is going to run like a lot. Whereas if you just left it a constant temperature without a programmable thermostat and dropping it. But there might be a case to be made, like if you're doing a passive solar house or something as well, just having these barrels, hopefully you can get the winter sun to connect with black thermal mass, but actually just having barrels like this inside the warm part of any building, like let's say you have a house with a crawl space or something, and I'd get plastic barrels because you don't need the solar heat transfer. It's just thermal mass. And you put barrels in your crawl space and fill them with water. That's just a mass to the house. So once the house or whatever building is up to temperature, that water's kind of up to temperature too. So it's going to take longer for your house to freeze or change in temperature. So if there's a power outage in the middle of winter, it's minus 50, and you have a building that doesn't have any thermal mass whatsoever, it's empty, doesn't have any furniture, or a house that's packed, has thermal mass tanks, even better if it's passive solar, the one with all of that stuff and mass in it, it's going to take longer for it to, get to freezing or change temperature than the house that's completely empty. So the rainwater, again, it's thermal mass, but I'm going to protect it from the sun because I don't want algae in my rainwater. This, I want it to hit the sun as much as possible because this is just the solar mass. So let's leave it at that. I guess, one more thing. I painted this part of the door black. So all my doors are black where the sun's going to hit it. It's just I want absorption and reflectiveness depending on the situation. Actually, one more thing before in one of my other videos, I talked about putting solar evacuated tubing on the inside of the greenhouse. I've got a idea for why that might not be the best idea. So again, I'm only going to get so much sun coming in, and it's either going to absorb or it's going to reflect all the light colored stuff. So there's only so much sun coming in. So on my roof that's outside, I'm thinking the solar evacuated tubings and then pipe it in to tie it into the in-floor heat system. But that's just extra sun area that's not part of the sun area of the greenhouse. Because if essentially I'm using all the sun, I want the plants to take it, I want it to reflect to help the plants, and I want it to absorb. I can't make more sun to come in, but what I can do is give it more surface area or get more sun by being outside and plumbing it in. So that's my theory for that. And those solar evacuated tubes are not a lot of thermal mass. That's your heat collection. So there's only a little bit of glycol in those, not a lot. There's a lot of water in here, so that's thermal mass. And to plumb these all together and run somehow pipes inside and a million different fittings, I thought that was too much work. So I could get solar evacuated tubes, bring it in and plumb it in here to help heat this. But I'm just leaving this passive. When I do the active part of the system, in-floor heat, solar evacuated tubes, coil around the wood stove and wood stove chimney, all tied together with a pump and a great big insulated transfer tank for that system. Then I'm just going to use a separate tank, and I'm probably going to put it on top of a really structurally well-built sauna and bathroom is where I'm going to put that. Okay, I hope that was helpful information. There's not a lot of information about especially stuff like this, how to do it properly. So water, fish oil, 1-inch headspace, cap just lightly on but enough for expansion contraction, no plywood, so there's room so that barrel's not going to collapse and it's not going to explode. It can move with the temperature changes. Another thing, oxidation is probably going to occur on the outside of the drum, not so much the inside, even though it's water and a little bit of fish oil in the inside, because of condensation. So for example, I filled it up from my well, and well water is like close to freezing. It's very, very cold. So when I filled it up, these warm barrels with ice cold water, I had a lot of condensation on the outside. Within 24 hours, there is no more condensation on the outside. So it'll be interesting to see when the sun hits it and then at night and cools off, if I'm going to get condensation on the outside of the barrels. So I think I'm going to get my flat paint like I did this one and paint this whole system, another coat of flat paint for if there is any condensation on the outside that can oxidize, which will eventually rust and wreck your barrels. So, and again, there's not a lot of information on, so how long is this barrel system going to last? I'm hoping many, many, many years, but eventually it will have to be replaced. So, but it does work better than plastic barrels. So if that information was helpful, hit that like button. It helps the algorithms. Leave me a comment. If you have another idea or something to add or a question, I'll try to get to it. Give me a comment. If you're not a subscriber yet, please subscribe. We do appreciate that. And check out all my other videos. I'm kind of doing these videos as I slowly myself build this this sucker, but getting into some of the fun stuff, it's really enjoyable. Like first you have to build the thing to be able to spend the time and do the good gardening and do the cool, fun little projects. So like, subscribe. Thanks for watching. We'll see you next time. Warm in the winter, but also super cool in the summer. So nice.